Yes, class. Am I audible to all of you? Who all have joined?
Yes, ma'am.
Deborah, Faiza. Faiza, where were you? After a long time, you have joined, Faiza. Yes, Faiza. Fia, Humam, Rajita, Shahid, Shavez, Fadil. Yes, Faiza, where were you? Why were you not attending the classes? I think ray optics you have hardly attended. We are now towards the end of ray optics. What happened, Faiza? Okay, okay. Now how's your health? You fine, Faiza? Okay, class. Now starting with simple microscope as we cold but better. Okay, Faiza. Let me know if any help you need of the classes, no, that you have missed, because we are towards the end only. Now only devices are left. Microscope, telescope, prism only. Okay, so yes, simple microscope we have to start with. So simple microscope is what? A simple microscope you can say, or a magnifying glass you can say, is just a convex lens having a small focal length, which is used to magnify object. Simple microscope is present in your, you can relate it with that also. It is present simply in the magnifying glasses. Now, how does it work? We will be seeing two cases. When the image is formed at least distance of distinct vision, this means final image is formed at least distance of distinct vision. This means what? This means that your image is formed at D, capital D. Yesterday we had seen 25 centimeter separation. Yes.
This is the last part of the chapter.
Microscope, telescope, and prism. These devices are the last part. In devices, you have microscope, telescope, and
Is
prism.
refracting telescope there?
No, refracting telescope is a very small portion. Telescope will not take any time. Focus on microscope. Telescope, I'll tell you, lots and lots of types of telescopes are there. Don't do all these. Galileo, different are there. I'll tell you when we'll come to telescope. All right, so two cases we'll see. In first case, we'll see that final image is formed at least distance of distinct vision. Means image is formed at 25 centimeters. In second case, we'll see images formed at infinity. That is the far point. Yesterday also I had mentioned. Now see, starting with the figure. This is the principal axis. Derivations will come. Pay attention, class. This is the lens. This is the lens. All right. Now, let's say object is kept. Some of the rays we'll be marking because we need these for the derivation. This is the derivation. All right. So first understand the figure. Derivation is easy. It's just based on the similar pattern. Till we come to telescope, you will be able to derive it on your own. All right. So this is the object A, B. Now one ray is passing. This has got refracted due to this. Fine. Now second ray, as I've always told you, this passes through the optical center. This passes through the optical center and it retraces itself. All right. Now, where is the human eye kept? Human eye is here. We look from here. When you see, no, you see the image formation. See, human eye is kept here. You see the image from here. This is just a construction part to tell you for the derivation purpose. You know how microscopes are constructed. So where you put the eye, this is the part. Types of microscope, details about the microscope, every instrumented portion of the microscope, this is now deleted from your syllabus. Don't revise it, and wherever you see those questions, don't even learn it, because parts of microscope and all, this is not in your syllabus, not even in biology. So physics mein to in any ways it's not there. Now see, these are the rays. Now what we'll do? We'll produce them. See, if we produce this, if this is being produced, so somewhere here we'll get, no? Like this, if you'll join, here you will get. Just draw it with the help of skill. It's difficult to draw it on the screen like this. So here we'll have the image. This is A dash, this is B dash. I'll take one more thing. Exactly at this level, I'll mark a point A double dash also at the exact point of it. Because somewhere we will be requiring this, and out of this, we want to relate it with this. Fine. So this is it. Also, one more thing. One angle I am taking from here. From this point only, one angle I am taking. Now let's mark all these angles. Two angles we are seeing. One angle is this. What is this that I have drawn? Or if you want, I can draw it separately also. Let me tell you separately. See, before the lens, before the refraction occurred and everything occurred, I just had the object. I just had the object that was AB. Fine. All right. This was the object. This is here you have the human eye. Means from here you are viewing it. All right. This is before the lens came and everything. Before everything, you have started, microscope started its working. All right. You have put the object at least distance of distinct vision. This is capital D, and this must be subtending some angle alpha. This is that alpha which I have taken. That's why I have taken it at this level. Now see class. Very carefully hear this. Otherwise, it will be very confusing. Understand it separately from here first. Understand it separately from the other figure first. And then from here, look. This object was kept at least distance of distinct vision. I didn't put the object in the microscope to magnify it. This is the first case. Understood? What is alpha? Alpha is the angle subtended by image object at least distance of distinct vision. See, if I see a pen which is kept in front of me, is there a lens? No, we are just able to see it directly from our eyes. So this is that case. Once the lens is put, you can see the modification. This was alpha. This was supposed to be alpha. This part only, exactly at the length of object. Okay, again, this is not made. Array class, just whenever you're drawing it, no, draw it from this point. I thought this is... At this point. Now see, this one is the object, this part. When the object was kept at the least distance of distinct vision, means at a separation of 25 centimeters, which we have seen, where you are able to clearly able to see the image. This is that triangle. Then the lens was kept, so you can see the change. This is the enlarged view. This image is subtending some angle. This bigger angle, that I'm taking it as beta. This bigger angle, I'm taking it as beta. Clear? So what is magnification equal to? Angular magnification, it is the ratio of angle subtended by image and object on eye when both image and object are on least distance of distinct vision. Understand this. When the image is formed, this is the image. Image is at least distance of distinct vision. It means this separation is D. When the lens was not put here, where was the object? Object was at D. So alpha is angle. This is the angle subtended by what? This is object. Subtended by object at I. angle that is subjected at I. This is the object kept, which is kept at least distance of distinct vision. Kept at D. Clear? D is what? D is least
Ma'am,
distance of distinct vision. So when the object is kept at least distance of distinct vision, the angle that is subtended is alpha. What is alpha? Angle subtended by the object. This is our object. AB was the object. This is subtending some alpha angle at the eye. And where is the object kept? Exactly where it is visible to us without the lens.
ma'am,
Yes.
D is the in both the figures D is different.
No, D is same. D is same in
Uh,
both the figures. In the second case, no, in this bigger figure, this one, lens part, we have not kept the object at D. Here also D is 25 centimeters. It's just that, have you ever seen microscope? You keep on adjusting it until you see the image clear. So object is not kept at D. You adjust it. Slide forward, slide backward. Accordingly, you adjust the lens also. So this separation can be anything. It will be less than 25, but it can be anything. But image will be at T is equal to 25. Why? Because you will be able to see it
okay.
from here only. If image is formed at 1 centimeter from the lens, you will see it blur. Okay, so that's why this was there without the lens, because once lens is kept, then image has to be there. This is clear, Chavez?
Yes.
Okay. This is the case. Class, understand this first one, this first case is when the object is kept at least distance of distinct vision. Why at 25 centimeters? Because yesterday we have studied that this is the near point. To see an object clearly, you have to put it at 25 centimeters minimum to see it properly, clearly. This is for human eye, least distance of distinct vision. So without the lens, directly you see the object. Put it at 25 centimeter, you will be seeing it perfectly. And that angle that will be subtended will be alpha. When lens is kept, you see the difference. Image becomes enlarged. So we adjust the object, adjust the lens using microscope has devices. It has the rotators to adjust it. We do it so that we see the image at 25 centimeter. When object was kept at 25 centimeters, we were able to see it clearly. Now when image is kept, we'll be able to see it clearly also. So the angle that this image is subtending, this is this beta. So what is beta? Beta is the angle subtended by image, angle subtended by image on human eye kept at least distance of distinct. So here magnification, what is magnification? Ratio of angle subtended by image. Which angle is subtended at image? Alpha or beta? Angle subtended by image. Tell me, class.
Beta.
Beta. Very good, Chavez. By image is beta. And you can see by object is alpha. If you want, you can neglect this also. You cannot draw it. You can forget that also and you can write it separately. So magnification is basically beta by alpha. And I have told you so many times that whenever you have small angles, you can write this equal to tan beta also, this equal to tan alpha. Why? Because whenever angles are less, beta and tan beta both are same. Alpha is equal to tan alpha. So you can substitute in here. Now we have to find out what is the value of tan beta. What is the value of tan beta, right? From here, if you see, if I take this beta, one angle if you take, this will be simply AB by OB if I take this smaller triangle, fine? And when I take alpha, tan alpha, it will be A double dash B dash by O. Or from here only take, if this is O, this will be AB by BO, correct? This will be AB by BO. And when we are talking about this, since I have taken this as AB, that's why I don't want to mix this figure. Let's forget this for the derivation. Look at this bigger figure. I want to write tan beta and I want to write tan alpha. These are the two things which I want to write. Fine, class. So one angle is this. So this beta will give me the angles for the bigger one. Correct? And for this smaller one, I have the triangle alpha. So what can I write? I can further write magnification equal to AB divided by OB into, this will be OB dash divided by A double dash B dash. And you know A double dash B dash is B double dash. This is equal to exactly AB. A double dash B is equal to AB. Look here. I told you, no, I'm taking this exactly at the level of AB. That's why, because I didn't want to take this separate figure. Otherwise, you'll be very confused. You have to draw this and put ABCD exactly as you have drawn this. So directly learn from here. A double dash B dash is exactly equal to AB. Now what we can do? We can substitute A double dash B as AB. So finally, magnification, this is there, both of these are equal, so you can say magnification is equal to this will be AB by OB into OB dash by AB. AB will be cancelled. What is OB dash? OB dash is the image distance. OB dash, that is least distance of distinct vision, 25 centimeters, D. And since this is kept in front of the lens, we'll take it as minus D. Clear? We'll take this as minus D. And what about OB? OB is the object distance. OB is the object distance. Let's write it as minus U right now. So M currently, this is equal to D by U. But we know what is U. You already know what is U. This will be minus D by minus U is equal to D by U. You have already studied lens formula. So you know 1 by F is equal to 1 by V minus 1 by U. So 1 by F is equal to, what is image distance? Minus D. This is missing. So from here you have to calculate. Understood? You have to put in the value of U. From here, are you getting this? This is lens formula. Yesterday we have studied lens formula. 1 by F is equal to 1 by V minus 1 by D. 1 by U. So from here, you can write 1 by U equal to, this will be 1 by D plus 1 by F. Put in the value of 1 by U here. This is U. Put the value of 1 by U. 1 by U is 1 by D plus 1 by F magnification into D. 1 by U to D. Put it, open it up. Open up the brackets. This will give you magnification will be equal to D by D plus D by F. D by D will be cancelled. Magnification is 1 plus D by F. First, tell me class, is the concept of alpha and beta, these figures are clear to you, or should I repeat it once more? This is clear to both, to all of you? Both the figures?
Yes, ma'am.
Clear?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Okay, very good. If this is clear, I'll just repeat it quick because once I just have to focus on one. Rest others are same, just slight differences. Here image is formed at 25 centimeter. In the next case, image will be at infinity. Easier. Second case, you'll prefer. Without the object, without the lens, I just had the objects. If I want to view a pen with which I'm writing, I'll put it at a distance of 25 centimeter from my eyes. 25 centimeters is not a very huge distance. I'll put it 25 centimeters from my eye. Even you people must be knowing that the computer's level or the books with which you read, it should be, especially books should be at an angle of 30° with 25 centimeter separation, because that is the least distance of distinct vision for human eyes. So without the lens, this was the case. With the lens, image expanded because of the refraction. We produced the image, we saw this image. I just took at this exactly at the level, so that what am I drawing over here? This is visible to you in the same image. Fine. Alpha, beta were the two angles, and magnification's definition is that it's the ratio of beta and alpha. You have two triangles with you. You have this triangle ABO and you have this bigger triangle also, and one is this triangle also. So using that, you put the value of tan beta and alpha, calculate it. Once you will calculate it, you will get it as d by u. You will be stuck over here. This will finish your answer. You cannot calculate further. D by u. So what we use? We apply lens formula. From lens formula, we find the value of 1 by u and put it here. Then simple multiplication, opening of brackets, 1 plus d by f. Write it down quickly, then we'll see the second case also. And please keep on updating me in the chat column, done, still doing, and all.
Ma'am, the definition for angular magnification, is there anything after at least distance?
Distance of distinct vision.
Okay.
Done.
Yes, ma'am.
Doing or done?
Done, ma'am. Done, ma'am.
Okay, okay. See, in the
Done.
second case, I'll draw it here only, though I have it, I have written it separately. In this case, this will be case 2, and image is at infinity. Final image is at infinity. I hope you all have drawn. So this part will be the same exactly. Without the lens, when you want to focus on the image and see the image, see the object, you will keep it at 25 centimeters. So this will be as it is. But here there will be a difference. This here you will have a slight difference. See, this is the object kept alpha, beta. If the image is formed at infinity, can anyone tell me where the object has to be kept? If the image is formed at infinity, where is the object kept? We have studied this initially.
Between O and F.
Yes, Shavir?
Between O and F.
No, not between O and F. Try to recall.
At F.
At F. Good. When you keep the object at focus, images are formed at infinity. When you put the image at the opposite, just vice versa. We have seen no, both the cases. When you, yes, on focus, exactly, Fadil, on focus. If you put the object at infinity, image will be at focus. If you put the object at focus, image will be at infinity. So here, if the final image is formed at infinity, it means this object distance, this is not actually object distance, this is the focus. And see, keep on producing them. These lines won't meet. This will be formed at infinity. In the derivation part also, you have the derivation not as complex like this. From here only, half of the load will be done. Look here. This part will be the same. Definition of angular magnification, everything will be the same. It's just that infinity will be subtending angle beta here. Alpha is the same. Still alpha is the same. So magnification is basically you have AB, tan beta you have to write. What is tan beta right now? Height of the object divided by the focus. If you look at this triangle, AB by BO, that is height by focus, right, in this triangle. So simply magnification. From here, for magnification, you have the value of tan beta. Tan beta is H by F. What is tan alpha? From here, tan alpha is Y, same, AB divided by D, same thing. That is H by D, or instead of H, you can write AB also. Because we have been writing it as AB, no? AB by F, AB by D. Now you take their ratios. So this becomes AB by focus into D by AB. AB will be cancelled, magnification will be D by F. That's it. No need to write this, all these. Please don't copy this. This was for the first case. Quickly write down the second case also.
Ma'am, here there is no alpha.
Alpha is there, still alpha is there, this. Because in the last case, no, there was a proper image. So I could take this and mark and draw it here. Right now, image is formed at infinity. These are parallel lines. Draw it with the help of scale. These will be parallel. So it's no point of taking. Where would I mark this? So exactly is this. In the last case also, you could have directly drawn it from here, written it. Only write this portion. I haven't erased this. This was from the previous one. Only this part. See, this question says the converging lens of focal length 6.25 centimeters. So what's the focal length given? Focal length is 6.25 centimeters is used in magnifying glass. This is magnifying glass. If near point of observer is 25 centimeters, near point, so you already know this is mentioned in the question. It can happen that this is not mentioned. This is D, capital D. The distance from which exactly you are able to see the object clearly. From I, calculate distance of object from the lens. If near point observer is this, you are the image is this is the first case. This is giving you a hint that image is kept at the first case. In the first case, the way you had image formed at least distance of distinct vision. So image distance will be minus D, that is minus 25 centimeter. Question will not give you minus you have to put. So first part is asking you to calculate object distance, right? This is the first part. So object distance, you don't need to calculate it from anywhere else. You know focal, you know image distance. You can use simple lens formula. 1 by U will be equal to 1 by V minus 1 by F. 1 by F is equal to 1 by U minus 1 by V. So from here, this will be 1 by minus 25 minus 1 by 6.25. So this will be 1 by minus 25. This we can write it as 4 by 25. So minus 5 by 25. So object distance is minus 5 centimeters. So this is kept in front of 5 centimeters from the lens. First part done. Angular magnification. Second part, angular magnification M is equal to 1 plus D by F. So 1 plus, this is 25. Yes, one thing I forgot to tell. Here you don't have to put any sign convention. No sign conventions are used in microscope or any type of microscope, simple or compound. 1 plus 25. Why I used here? The reason was that I was using lens formula. And in lens formula, we put the sign convention. Please do remember, I forgot to tell you that time when you were writing, no sign conventions. This is the only portion in ray optics where you do not put sign convention in magnification. Like here, 1 plus 25 by focus. Focus, what was the focus? 6.25. Write it as it is. So 1 plus this was 4. So magnification is 5. Third part. This no. Minus, this is for lens formula. Third part, angular magnification and final image is formed at infinity. So for that, you do not put the 1. You just have D by F. That is 25 by 6.25 is equal to. Write it down wherever you're not understanding. Ask me, get it clarified. But remember one thing, write it down somewhere at the corner of your notebook or where you have put the formula in the box, that you don't use sign convention here. Lens maker formula, lens formula, every portion which we have studied, I have mentioned that use sign convention. Here you do not use sign convention. In the first part, I have used sign convention because that was not a part of microscope or telescope. That was lens formula where we generally use. But in angular magnification, in these two parts, no sign convention will be used. Write it down.
Can you read the last point? When final image is at?
This is infinity, at infinity. Second microscope that you have is compound microscope. This is the last portion of microscope. So compound microscope has two lenses. It consists of two convex lenses, one of short focal length and short aperture, and it can magnify 1,000 times. So when you look at its construction, you will see objective lens. It is positioned near the object to be magnified. Convex lens of very short focal length and short aperture. So two lens, one is objective lens. Second, you have eye lens, which is positioned near the eye to view image. It is convex lens of comparative large aperture and focal length than object. Fine. So image I'll not draw because it is very vast and it will take a lot of time. So when image is at least distance of distinct vision, you can see from here. This is the objective lens. This is the eyepiece. Now focus on each ray properly. Look here. Here the object was kept. One ray. Look at this carefully, class. Or should I zoom it more? I think this is fine. All right, look here. So when the image is formed at least distance of distinct vision. This is the case initially. AB is the object subtending angle alpha at the human eye. This is the object AB kept. Now one ray gets shifted here, refracted. All right. This is the second ray which passes through the optical center. And both of these intersect at a point. So you have the intermediate image first, that is A dash B dash. But since here one more lens is kept, so the rays which were going, they'll also again get refracted and finally enter into our eyes, where the eyepiece is greater. It's greater than the object. This is reverse in case of telescope. So now when you produce it, when you produce these lines, you see a final image which is enlarged. 100 times it is magnified. So two object distances, two images you will see. This is the objective object distance. This is the image distance from the objective lens. Then this is the object. See this intermediate image, this image which was formed. This acted as an object for eyepiece, right? These rays got refracted and an image was formed. But since there was one more lens, this image acted as an object and the light rays bent and got refracted. And finally, we had the image. So image is formed at least distance of distinct vision. Here you can see this is capital D. This is the focal length of this. Focal length, one focal length is here, focal length is here. Its focal length is here, eyepiece's focal length is here. So everything is clearly made. Now see, when you will see magnification also, the same thing will go for angular magnification, ratio of angles subtended by eye and all. Same thing. Now see, magnification will again be beta by alpha, same thing, tan beta by tan alpha. This is fixed, same thing. When you're talking about beta, tan beta, if this is h dash, height of this, we can write magnification, tan beta I'm writing, h dash by, this is h dash, this can be written as h dash by this. This is object distance of the eyepiece. So UE. Coming to tan alpha we know initially this is height of object by the least distance of distinct vision. Correct. So this will simply be, initially we'll multiply it by height and this will go up, that is D. This we'll have H by D, right. So this we have. So we can write this as h dash by ue into d by h. Now one more thing, magnification of objective lens. We know this is already h dash by h. What is h dash? H dash is height of image. So we know magnification is height of image by height of object. So what you can do, remember one thing. Magnification of objective lens is this. Magnification of eyepiece is d by ue. So magnification, you can always write magnification as, always write magnification as m naught into me. That is magnification of objective lens. This one into magnification of eyepiece. You can always multiply and you can always use this relation. Clear? Now look. One more thing that we have already studied. Objective lens is a normal lens which we have been studying it. And what did we see? This is always magnification is image divided by object. So this will be V naught by U naught. Now see, this is for you. You can remember it. Coming to this final formula of ME. ME can be written as D by UE. Right? This can be written as D by UE, which you can further put the values. Like, look here. This is ME. So you can write ME as D by UE. And what was left? This was M is equal to M naught into ME. So M naught ME you can write D by UE. Also, this acts like a simple microscope. Whatever you have studied for simple microscope, this acts as simple microscope. So you have already studied about simple microscope. What have we studied about the magnification of eyepiece? You can write the magnification of eyepiece as 1 pi d plus fe. So what is m naught? M naught is v naught by u naught. Me is 1 by d plus fe. So what will be the final magnification? Final magnification is the product of both these. How do we know that it's the product of both these? Look here, class. Firstly, let us solve this. How do we know that it's the product of both these? Because when we had seen the ratio, we had seen that h by this is magnification of objective lens and this was magnification of eyepiece. That's why we could write this. Is it clear? First tell me, class. Is this part clear? Why m is equal to m naught into me? So what you can do, finally you can write V naught by U naught. Then for E, you can write 1 by D plus Fe. This is the formula. Write it down. Compound microscope.
Ma'am, can you explain me the figure again?
Okay, Fia. When you will be writing it, I'll explain it.
Thank you, ma'am.
See, Fia, here you have the object kept. First ray of light passed through the objective lens and it got refracted. Then the second ray passes through the object. This is a simple case of simple microscope, the way you have seen. It passes through the optical center, retraces itself, this case. Now here there is an intersection, so an image is being produced. This is the intermediate image, first image. And since one more bigger lens is there, so we have this as our object now. This was the image of the objective lens, which will act as the object for the eyepiece. So again, the rays pass through the lens and they get refracted and finally enter into our eyes. But human eyes have the tendency to see in a straight line. Light travels in a straight line. This property you must be knowing. So we cannot see the image like this. We cannot see the object's image like this or back to like this. No, we can see it in a straight path only. So we produce it. We always straighten it. You must have noticed this. Finally, this is the final image that we have obtained.
Okay,
And
ma'am.
these are
Because
the
of that, we are seeing more enlarged image
more
than
enlarged.
simple
Yes,
microscope.
because two lenses are there. So more of magnification, and this is of larger aperture also. Okay.
Yes, ma'am. Thank you.
Okay, it's one case of this is left. Then we'll move to telescopes that I'll complete in the next class only. All those who have completed, you can start leaving. Time is already up.